Hi, very good evening. My name is Ayush Swastav, and I'm here to present my DSA assignment in or LeetCode assignment in which basically I have to solve a medium level difficulty problem of LeetCode. Yeah, so let's start my video. Let me share my screen with you first of all. Yeah, so my screen is visible now. Now let's move on to the question. Just what does it says? Okay, so my question name is DSA Quest 2 LeetCode Homework Set 2. In which basically it says that you are required to submit a video solution for any one medium difficulty level code problem. Please note you must follow the following three steps. Basically, it says that I have to create a video solution for a medium difficulty level lead code problem, in which basically some guidelines are given. So the most important guidelines I would like to grab attention towards it is that I have to basically tell you the approach of my question, that how I approach the question, how I've done the solution. I also explain you the brute force method. Basically, in starting, I will tell you the brute force approach of that question and how to make my solution more efficient or more optimized. Basically, so this is how I have to tackle the problem. Yeah, so let's start. Let's see the question. Okay, so my question is basically question number 53. Its name is maximum subarray. It says that given an integer array nums, find the subarray with the largest sum and return its sum. The example is here given as this one. It is basically telling me that there will be an integer array. There will be a given array under which some integers will be there, and the name of that integer array is nums. I have to find a sub array with the largest sum and return its sum. Basically, what I have to do is that I have to find the largest sum with a there will be a contiguous sub array under which there will be the largest sum of that sub array will be there, and I have to find that sum. What would it be? Like in the given example, minus 2, 1, minus 3, 4, minus 1, 2, 1, minus 5, 4. The largest sum, okay, the subarray with the largest sum would be 6, and the subarray will be 4 minus 1, 2, 1. 4 minus 2, 1. Okay, so basically, I have to find that contiguous subarray and its sum, and I have to return its sum that with the largest sum. Like in this case, 4 minus 1, 2, 1. This is a contiguous subarray. What is a contiguous subarray? In which the integer of that array are in the given are as same as the basically the order of the integers in that subarray would be same as in the given array, like this 4 minus 1 to 1. It is in the same order, and I have to find that subarray in which I can take as much as elements I can want until I get the maximum sum possible. uh, in the case of when I'm trying to find the contiguous subarray, I have to basically find the maximum sum that I could get from that particular contiguous subarray. In this case, that contiguous subarray is 4 minus 1 to 1, and the sum is 6. This is 1, so basically sum will be also 1 because there's only one element. In this case, the maximum basically when I'll add all these elements, the largest sum is only can be extracted when I'm taking all the elements of this array. Like 5, 4 minus 1, 7, 8. I'm not actually taking the sub array in this case. I could simply say that I'm taking the whole array, and the maximum sum could only be extracted when I'm taking the whole array. So this is how this question is need to be solved. This is what the question is telling us. Now I'll tell you the brute force approach of this question. What is the brute force approach? Basically, brute force approach fix you that tell you that there is a particular solution existing for this question. But when I solve a question with a brute force approach, it will take a lot of time and space, and it is not an optimized solution. It will work for smaller arrays or a smaller problem, but when I'm taking a very large array, it will not work for that. That is a brute force approach. So the brute force approach in this particular case is that I can basically I will take all the possible sub arrays and then calculate its sum, and then I'll check that which sum is the largest, and then I'll return it. What I mean to say is that, like, first of all, I take this sub array minus 2 1, then minus 2 1 minus 3, then minus 2 1 minus 3 4, then minus 2 1 minus 3 4 minus 1. Like, I'm taking all the possible sub arrays, all different. There can be many possible sub arrays. Like for a larger arrays, it can be hundreds of possible sub arrays. So I'll take all that sub array and then add every integer of that sub array and take out the sum from it, and then I'll check that which sum is the largest, and I'll return it. So basically what happened in this kind of approach that it will take a lot of time to get that subarray and calculate its sum. So it will be not an optimized solution. It will take a lot of time. The time complexity will be larger. It will take a lot of space as well. So that will not be an optimized solution. So for an optimized solution, what I am doing is that I am approaching a cadence algorithm. I am doing this solution by cadence algorithm. So what is the cadence algorithm? So basically this is an algorithm used in generally these kind of problems in which we have to find the maximum sum, uh, find the a contiguous subarray with the maximum sum. This is an algorithm used in generally this kind of concept in which we have to basically extract a part of subarray and which will have the largest sum. This algorithm is basically used in that cases. This this approach will be the time complexity of this approach will be very much smaller in comparison to the brute force approach, and the space it taken by it will be also will be even much lesser than in comparison to the brute force approach. So that's why I'm using the cadence algorithm here. Now what I'm this is a very short code. Let me explain now. Coming to the code, I'll explain it how I have written it and how does it works. Now first of all, I have taken two different, basically you can say, variables, that is integer max, that is will be num0, nums and index of first index, integer current max equal to first index. Okay, so I am assigning the same value to both max and the current max, that is -2, the first element of the array. Now I'll iterate the array with using the for loop, and I'm using that is current max equal to math.max num psi plus current max, then max equal to math.max current max and max. Now what is happening here is that the loop will iterate and start that loop will start from 1, not from 0, because this is the condition of this algorithm that these two variables will be will have the value of the first index, and the loop will iterate starting from the second index or the index number 1. So that's where I've taken it from, and it will iterate to the last element, and then after each uh, iterating over each index or each element, the value will get updated. Now in need to be understand this particular logic, that what I have written here, I have to basically explain. I can't explain it in words. I need to explain it by using a pen or a kind of a drawing or letters. That's why I've used an Excalibur. That will be because I'm using this because it will be easier for me to explain that how I have approached the this particular logic and how is it working. Basically, I'm using the dry run method. I'm dry running this code to explain how does it work and how it will return the maximum sum. Okay, so let's start. I have written here the main array, that is there are three examples here, but the first one is quite bigger, so that's why I've taken the third one because it will be shorter. It will be short. It will be shorter to explain, and it will not take a longer time. That's why I've taken the third. That is 5, 4, -1, 7, 8. This will be the given subarray. Okay. Now, what is happening? First of all, what is my approach? My approach is that the loop will start iterating from the second element or the first index. What would happen? The I will be 1 and 1. Now, nums I, that is first index. 0, that is I will be assigned to her, and it will be the first index. That is 1 in this. Sorry. That is 4. Sorry. The integer max will be assigned the value of 5. The current max will be also assigned 5, and then after the loop will run. Now for the current max, the value of the current max and the max will get updated after each iteration of the loop. Now max number nums I. Now the loop will start iterating from the second element, that is 4. So what would happen? Num first I1, that is nums1 will be equal to 4. Okay. So what would happen? This will be equal to 4 and this will be equal to 4 plus current max. That was 5 in the previous case. So 4 plus 5, 9. So this will be 4. This would be 9. Now math.max. So it will select the larger value from both the values. So 4 is not larger, 9 will be larger. So the value of current max will be updated and will become 9. Okay. So let me write it that the value of the current max is basically getting updated. So it will now become 9 and not 5 anymore. 5, the value 5 will be now removed. It has now become 9. Now in the second step, max will be equal to max current max and max. Now max is basically 5 in the first step and current max is 9 here. So max 9 and 5. So 9 would also be selected for the max as well. The max has become now max also become 9. So the value 5 will be removed and the value is getting updated to 9. Okay, this is also updated to 9. Now the value of max current max is now 9. Now I will update it and it will become 2. So the 2, so it will be the third index 0, 1, 2. So the value will now I of value, so the value will be 2. So nums I, this will be 2. So nums 2 will nothing but 9. Sorry, nothing but minus 1. So the value of nums 2 will minus 1 and this will be minus 1 plus current max that was 9 in the previous step. So 9 minus 1, 8. Okay, this will be 8 and this will be minus 1. Now I'm taking the maximum value, so I will take 8. So the value of current max has been now updated to 8. Okay, so let's write 8. And what would happen is that the value of current max would be updated 8 and the previous value will be removed. Now, as the value of current max is 8 and the value of here and the value of current max is 8, but the value of max in the previous step was 9. So it will remain the same. Okay, 9 and 8. So mat.max, it will take up the value of 9. So max will remain 9. Nothing will get updated here. Now the third step. Now it has become 3 now. I is 3. The nums 3. That is 0, 1, 2, 3. So 7. The nums I will become 7 and this is 7 plus 8 in the previous step, 15. So the value of current max is now 15. Let me write it for the sake of easiness. Now it has become 15. The value of current max has been updated and it has become 15. Now mat.max, current max of the value of current max is now 15 and max is 9. So what would happen? The value of max will get updated and it will become 15. The value of max has also been updated and it has become basically it has also become 15. Okay, so we'll write that it has become 15 now. Now next again, I will now become 4. 0, 1, 2, 3, 4, 8. Okay, so what will happen? Now current nums I, there will be 4. So basically it will simply be the nums I will represent 8 now. Now 8 nums I 8 plus current max. That was 15 the last step in the previous step. So 15 plus 8, 23 and this value will be 23. Here max.max, current max, max. Now current max is 23 and max is 15 the last step. So 15, 23, basically max will also become 23. Now the loop has ended and the value now it has become 23 and the max has also become 23. Okay, so as now the loop will end as the this particular array has been all iterated and the loop has been broken and the loop has come to an basically end. Now the last value that we have got is basically 23. Now what I'm doing is that I will return max. Okay, so the maximum value that I could get from the sub array of that array will be 23 in that case. So 23 will be returned. Okay, because the last step in the last step max was equal to 23. So we will simply return 23. Here I can see that output is 23. So in this case, the cadence algorithm is working and this question has been simply working how it should be working. This now let us move to this question. This question will also be approached in the same manner and it will also work, but as this is a very longer array, I have not taken it as an example because it will take a much longer time to explain. It was a shorter one, so that's why I have taken it, but it will also run in the same method and the value that we'll get in the last will be 6 eventually. So this is how this particular question has been working on the approach that I have used is cadence algorithm approach. Okay, so this is how the question working. Now we'll run the solution to see run the code to basically see the output. Now I can see that case 1, case 2 and case 3 all has been accepted, and when I'm submitting the solution, uh, The runtime and the memory both has been great. The runtime is also reading 100% using Java, that is 1 millisecond, and the memory is 50% 5 MB. The time complexity of this solution is basically big O of n, because this is a general no, general thing that the cadence algorithm always works with a big O of n time complexity. So this is how the code has been executed, and it is worked perfectly fine. Time complexity is also less, space complexity is also less, and it is very optimized and efficient solution using cadence algorithm. And this is how the assignment has been done. Thank you very much.